Hello guys, I'm a teacher in Juga Masame. Let us take a look on the question below and see how we can solve this question. We've given the nut and the bolt and the bicycle frame. The purpose here is to fix the nut into the bicycle frame tight by the means of the spanner. Then we have given the perpendicular distance between the axis of the nut and the line of action of the force F applied to the free end of the spanner is 0.15 meter. Now this is our spanner, this is a box spanner, and from a box spanner this point, this end is where our effort applied, and our nut is rotating clockwise directions in order to move into the bicycle frame to be fitted tightly by this spanner. And then the line of action of our force E40 now is perpendicular to the axis of rotation of the nut, and the distance from axis of rotation of the nut to the free end of the spanner is 0.15 meter as we have given here. And then we have given the couple of force, that is 10.5 Newton meter about the axis of the nut. This couple force is what produced by the applied force F. Now we are asked to find this magnitude of this applied force F, which is equal to effort. Now from a moment of force, we get M is equal to force times the perpendicular distance. Now when we substitute the values of moment of force, that is couple, at 10.5 Newton meter divided by perpendicular distance is 0.15 meter as given, then our value is 70 Newton. This force is enough to cause the couple of 10.5 Newton meter along the axis of rotations as it turns the nuts clockwise directions towards the bicycle frame. Now we've asked also to find the velocity ratio when we have given the distance between two successful threads, that is pitch, and it is 1 millimeter. Also we have asked to find the tensions parallel to the axis of rotation of the nut when the couple of 10.5 Newton meter acts. Okay, we have two things. I have asked to draw also the diagram to illustrate the answer. Our diagram, as you can see here, for the box spanner, and this one is for the flat nose pliers that we want to ask in this question to use pliers to turn this nut. For diagrams, we, as you can see here, finished this part, but for tensions we must first find the velocity ratio. Okay, this is a diagram for bolts, some part of diagram for the bolt. The distance between two successful threads is 1 times 10 power negative 3 meter. We must change this distance into meter rather than using the millimeter. Then the velocity ratio from definition is equal to distance moved by effort divided by distance moved by load. Remember that the effort here is applied at the free end of the box spanner. Hence, the rotations of this spanner, the circumference swept by this effort is corresponding to the effort distance when we times with the number of revolutions. Also, the motions of this nut from one pitch to another pitch, this motion is the one that give us the distance of the load. This nut act as things that a load, because there is opposite force, that is frictions, that we must apply the effort against in order to overcome these frictions. Hence this nut, the mechanism of taking this nut from one point to another point, it causes us to have frictions, and this frictions is acting as a load. Hence the distance velocity ratio is equal to circumference swept by the effort divided by the pitch. Pitch standing for distance moved by the load, and circumference swept by the effort is standing for distance moved by the effort now is equal to number of revolutions. That will be the same, and we cancel out 2 pi r. Keep it to r, that's the distance from perpendicular distance, and then we substitute the values and we arrive into the answer as you can see below for velocity ratio. Let us see how we can find tensions for all force applied parallel to the axis of the nut is corresponding to the friction force, or is equal to the load that used to be overcome by this effort. As you can see from here, the motion is towards the left and the friction force acted towards the right. Then from efficiency of machine is equal to mechanical advantage divided by velocity ratio times 100%. Then mechanical advantage is equal to efficiency times velocity ratio divided by 100%. We substitute the formula for finding the mechanical advantage as it's equal to load divided by effort. Then we make the subject the load. We can times the effort at these equations, and then we substitute the value, and hence the tensions or the load is that the magnitude of the force F used to overcome is equal to 66,000 Newton approximate. Okay, thanks for watching. Please like and share, comment, and don't forget to subscribe this channel for more videos like this one. Okay, thank you.